My slides right now. Yes, so I'm starting. Yeah, expert on everything. That's what I like to be. But anyway, yeah, then you raise the bar very high right now. So, but anyway, welcome to the Model versus Data Format mini web seminar on modeling. I want to introduce myself and my professional background. I'm Andreas Hege. I'm COO from Ra Consulting GmbH since 25 years right now, and I'm working there as an also as an software architect. Ra Consulting um, is a long year member of ASAM, of course, and yeah, it's my passion on modeling is on code generation, on domain and model-driven architecture and development. So wherever I can generate code out of whatever I get in a model, I'm happy. So that's probably best describe my background in the from the modeling aspects. So my ASAM backgrounds are from several groups. I was member of the TAB group, which is a rule-based validation framework for calibration. I was involved in MCD3, mainly in the diagnostic part. We were a member of the Open Data Services, which is about storing data and measurement files, and I'm an active member of OpenSCENARIO. Further, I have some background in ODX, OTX, and the standards I've already mentioned. Okay, let's first talk about the problems we wanna solve here. So some issues about modeling and about standardizations and about data formats instantly coming back, and I've had questions like, do we need a model, and can't we use XSD for modeling everything? We know XML very well, and as a domain expert, I'm just not interested or not as good in learning UML or some other modeling languages. And of course, what is the best modeling language? UML, IDL, RDF, something like that. We have already talked about how could we define our open scenario data model with the web ontology language. So that was one of the topics in, I think it was in open ontology or open label still. And this is also was also some aspect of modeling. So what is the benefit of UML? This is something that I'm faced with customers and also in standardization groups over several years right now. What is a meta model? Of course, that's all, some of the questions. And of course, the quest about the golden data format. So it just should be be able to do everything, to be human readable, machine readable, open source, tools available, read optimized, write optimized. What should we take to encode our domain objects? And last but not least, so there are a lot of terms around like UML, RDF, blunt UML, REST, and everything like that. So it's just interesting to look at each and uh, look at this from the aspects of formats and modeling. What is a model? What is a format? What is a modeling language? And that's are these are the usual questions we can tackle here in this webinar. So I have a small agenda here. We will have some talk about 90 minutes. I've not really access to the chat. So Ben, whenever you have some interesting in the chat, please just interrupt me, and then we will try to answer the questions. So my agenda is about modeling and models, the fundamental of models, just to have a look at what the purpose of modeling is and what models are. And then, of course, data formats, how we can encode our domain-specific object with data formats. So let them play together in standardization, data formats, and models. When we have interconnect standards and systems with models and data formats, we have some short chapter about meta models, and instances. And I gathered some quick tips which have some personal opinion, but probably will help you in our standardization groups. And then, last but not least, we have a Q&A, 30 minutes. So let's start right now. So what's in the scope of this webinar? Just to meet your expectation, or just to clarify the expectation, we want to increase the quality of communication, which means that by defining some terms, by giving you some insights and having a great discussion, I hope that we all increase this quality of communication. We want to work on the right problems. So this is the definition of effectiveness. So I think when we talk about the same things, we are able to work on the right problems then, and on the same problems, of course. Regarding ASAM standards by example, I took a couple of a few examples and put them with their data formats and their models right into this webinar, just to make it more visible, to see what we are talking about. We want to avoid pitfalls. I think that the ASAM Association has produced great standards during the last 25 years. Congratulations, by the way. And we can use this great experience and avoid also some pitfalls for the future. Okay, we want to raise better collaboration and modeling experts and domain experts. So that's always the case. So we have both of them. We have great domain experts in standards over all areas of science and engineering. And taking these together with a modeling expert, I think we can do great things here. And of course, I want to make you a little bit curious about the discipline of modeling. As I said, I'm just passionate code generator, and probably this is also something for you to be interested in. What's not in the scope of this webinar, just to make sure that we are not working, or we are not talking about some things that I couldn't probably deliver to you. So we will not work on concrete ASAM standards. I'm happy to take your questions during the Q&A. Also, when the questions are about some specific standards, it's all good. But so I think the working groups do this thing just to work on the concrete standard, and here probably we have some. We can clarify some generalized terms and practices. We will not deeply dive in some kind of data formats like XML or RDF or else, just to make sure that we do not do that, and we will not deeply dive in UML and web ontology languages or something like that either. So we are scratching on the surface right now a little bit, anyway, I think when it's going to be concrete and when we talk about examples, we will make great reuse for our ASAM standards. Okay. For an introduction, I'm showing you here the ASAM standards from the ASAM website. You're looking at the classical standards on the left-hand side, and we also have this OpenX standards recently. They all work greatly with formats and models, most of them. And this is what I'm just going to introduce you, that both models and data formats are crucial factors in our standardization groups. Models, we use models to describe the domain. The domain is, from my point of view, is the domain in a standard is a specific area of knowledge with the domain expert. And this area of knowledge is about engineering and science. So we describe our domain with models. We use often we use data formats as a normative output of our ASAM standards. So whenever we are defining or whenever we're working on a standard, so mostly when we want to share domain objects, we use data formats to do so. We often derive data formats from a model, which means we have some aspects in the model which we later meet also when we define our data format. So this is often the case when we work with data format and models. So let me just give you a short introduction into the fundamentals of modeling and models. And when we talk of modeling and models, probably something like this comes into your mind. I took a class model, UML class model from the ASAM XIL standard right now, and probably it is that when you think about a model has some kind of a class model with rectangles and lines in between. With in this case, we have classes, we have associations, we have inheritance, we have methods, we have enums and something like that. So this seems like a formal definition of that what our domain in XIL looks like. So probably this is something that comes into our mind. So first, let me introduce the purpose of modeling. So when we talk of modeling, we are talking always about a human way of coping with complexity, which means whenever we are faced with a complex system we want to talk about, we need some, that is the next, we need some simplified representations, which are called models of this complex system or phenomena, which is, this is all about our modeling. Models is then an abstract representation of an original. So what does original mean here? I mean, we can also talk about reality, and that's what we are sometimes talking in our ASAM groups. What does a model represent of the in the reality? So I want to prefer to use original right now. This is two reasons. The first one is that the model in many cases represents another model. And reality is really something that people can feel very different about it. So I prefer to use original here, which means that the model also represents something other, which we call then an original. Let's talk about modeling goals, right? And that's what we are seeing in many models right here, that models already have inherent modeling goals, which means that you cannot cleanly separate models from the goals of this model. So we do not have this one general model that explains everything, but when we have a model, it comes with its modeling goal. And modeling goal, just to give you an impression, what we are talking about could be, for example, descriptive, which means we are describing a complex system so that we can communicate on the basis of this model. For example, when we look at some kind of this class model, we have classes and association and everything like that, which just helps us to understand the complex system or the domain we are operating in, and to communicate on the basis of this model. We have probably predictive models, which is helps us to predict future outcome of a system. For example, a weather forecast. We have some weather models where the model makes us able, or makes the experts able, to forecast the weather for the next couple of days and even weeks. And it's predictive models are very popular also in simulation. You have a model and run the model and see what's coming out, and just to explore your domain by running a predictive model. And last but not least, you have also a predictive model in image recognition, in artificial intelligence. This is the process of identifying an object or feature in an image or video. This is also a good example for models that have predictive goals here. We also have prescriptive models. Prescriptive models we have when we want to produce things with a well-defined outcome. This could probably be a business process modeled in BPML. You model a business process and want to use this process for to produce a specific outcome of this process. Also, an IKEA a product assembly instruction is something like a prescriptive model, or a recipe for an apple pie is also some kind of a prescriptive model. So the modelings, the goals are probably very important when we later look on our model and ask ourselves, what is the modeling goal behind a specific model? So when we are talking of modeling as a process, as I said, we talk about a human process driven by two factors. First one is a creative factor, which means that whenever two people try to create a model for the same system, you could probably bet that the model looks very different, which means that the model or the modeling process alone can not just be measured by absolute or mathematic matrix, but also by the creative mind that stands behind the modeling process here. And the second, and we will meet here again, the modeling goals, is about when you are creating a model, you usually have in mind what problem to be solved with this model. So it is a descriptive, prescriptive problem, it is a predictive problem, and this will affect the model and the modeling process very strongly. That leads us to two observations. The first one is a single and complex system could be usually represented by different models with different modeling goals. So this is very, very important that whenever you have a complex systems, this might be represented by many models. And this is going to be important when we talk about single source of truth right now. I will give you here that what this I'm repeating this here. A single complex system represented different models with different modeling goals. So I have a funny example, I guess. We are talking of an apple pie right now, and we are looking at the complementary representation of the apple pie as a complex system. So when we look at this list, we have probably a piece of an apple pie which represents the original. And whenever you want to experience the taste of an apple pie, of course you have to have a piece of an apple pie just to taste it. Whenever you write, for example, in a newspaper about an apple pie, you might use some kind of an image of an apple pie just to make sure that people understand of what you are talking about. And this is something like a descriptive a representation of an apple pie. When it comes to nutrition facts, calories or something like that, or a simple list of what to buy when to make apple pie, that apple pie is also represented by an ingredient list, which is prescriptive and descriptive also. And whenever you want to bake an apple pie, you probably need an apple pie recipe in a recipe book. And just to look at these different representation of a single complex system should make you make you clear that whenever you want to represent a complex system, so probably one model is just not enough to represent a system. I give you an example. When you really want to experience the taste of an apple pie, you would probably not eat an apple pie recipe. And that's exactly what I just want to say. So we need different representations of a complex single systems with different modeling goals. And this leads us to the properties of a model. This is just some kind of a very old definition or very old aspects of a model. What aspect would be put into a model during modeling? So we have some kind of mapping features. So we have an original, and during the creative process of modeling, we are mapping these features from the original to our model. For example, if we have some kind of an abstract understanding of a class and a class diagram, we probably map this abstract idea of a class in a rectangle in a class diagram, which means that we have properties from the original that we map in the to properties and mapping features in our model. The next thing we have is abstraction features. So this is not about mapping. This is about disregarding properties of an original that are not considered relevant for modeling goal by the modeler. So this is also some kind of creative act, which means that when for the sake of simplicity, and that's what the process of modeling does, simplified representations of originals, it is sometimes just good to disregard properties, to only regard the properties that that help to fulfill your modeling goals. Which means you lose information from your original to your model for the sake of simplicity. This is really great since it's more simple. It's probably better to understand the model. On the other hand, you lose the general use of your models, and that's also some kinds of balancing. What features to be mapped and what features are disregarded during your modeling process. And last, it's called pragmatic feature. This enables the model to be replaced, to replace its original for the modeling goal. And probably a good example is some kind of a wind tunnel simulation. You have a small model of your, for example, of your vehicle, and send it to the wind tunnel and explore what happens during simulation, which means by studying or by exploring the model, you learn something about your original. So this is something you then have to decide when you're modeling. So we are now having some takeaways from this chapter, modeling and model. The first one is that models represent originals right now. So a model has inherent modeling goal. You cannot separate easily the model from its model goal easily. Modeling is a human process, had some creative factors in that, and an original is often represented by different models with different model goals. So we have talked about models so far, so let's talk about data formats right now. As for the models, we look what comes into our mind when we think of data format, and probably something like this comes into your mind. We are looking at encoded scenario from OpenSCENARIO 1.1. Well, the scenario is encoded in XML data format, and domain-specific nodes and attributes help us to understand the domain also, and also to share data among experts, among tools, and everything like that. So probably this is something that is pretty familiar to you when it comes on the discussion on models, on data format. Sorry. So I have some property examples of data formats. So when we talk of data formats, we often talk of encoding. So encoding is in particular way to encode your data when you represent, store, and transport the data, which means one writes the data, the other one reads the data, and that's what in between is often encoded data. So sometimes it's about human readability, machine readability. So human readability is usually about the fact that you're looking into the encoded data and really recognize what the encoded data looks like, and you can understand the encoded data a little bit. And machine readability means that the data is in a structure that machine to machine is really unable to read and write the data format. It's just more than an unstructured text. I mean, unstructured text also can be analyzed by artificial intelligence, of course, but we are just talking about the well-structured data format instead of the data-based analysis with AI right now. So machine readability is about just structured a structured way that make machines or computers able to read the data. Writability, it's ability to be written to the media. It's about editing when it's about human writability, and it's about how the data is written to disk or to cloud, to the cloud or something like that. So this is also about writing the data as a chunk, being self-contained or something like that. So this is always when it comes to writability. We talk about the payload when it comes to data format. So this is the part that of the data that actually transports the information. And of course, when we have payload, we have an overhead, and this is the part that contains data for directing or controlling the structure. If you think of XML, you have a lot of overhead here. You have the node names and everything like that on one hand, but on the other hand, it really helps you just to identify the structure when it comes to human readability. Okay, these are just some properties, and now let's talk about what's data format in standardization. There are probably a couple of definitions, and I choose the one that's also very simple, I guess, and I think it applies 99% and when we use standard formats in data formats in standard. So data formats are used to encode domain objects for representation, storage, and exchange. So as a standard describes a specific domain with its semantics and its rules. The data format is primarily used to encode domain objects of this domain and for storage or exchange, and sometimes also for representation. So this is the definition I would work with in our standardization groups. And of course, a format is used right here synonymously with data format. And in most cases, and where it applies, data formats are file formats. Not in any cases. I mean, when we talk of REST APIs or something like that so the format's not it's not only files we are talking about, but it's also about cloud connectivity or about streams or something like that. But in many cases, when we're talking of data formats or formats, you can also use file formats. Oh, we come to our first question: models versus data format. Is it something like what about the data format itself? And surprisingly, and this makes it a little bit complicated, is whenever we have encoded information in a specific data format, it represents an original. So whenever we have encoded data, whenever we have an instance of a scenario, for example, it is a model. So that was our original definition of a model, that model represents an original, and that's also the case with encoded data that we use in our standard, for example, to encode a domain object. And to make it even worse, a data format itself is also a model. It represents a concept of how to encode data, and probably this is one of the sources for misunderstanding that makes it a little bit difficult to talk about data format and model. So right now we are learning, unfortunately, a data format is also a model. And just to emphasize this, I just want to show you this picture again. That on the left hand we have a data format that represents an encoding concept, and we have data that is encoded in a specific data format like an XML, and the encoded data represents a domain object. So any of the two data format and encoded data are models. So far we are confused, but on a higher level, which is our next step right now. Anyway, Just to emphasize this, that encoded data and data format itself are models that represent something, encoded concept and domain object.
Andreas, maybe I know we said questions at the end, but there's 2 or 3 questions in chat that I think might be a good idea to address them before we move on further. I think there was one clarification when it came to a domain object. What do you mean with a domain object?
Yeah, that's a good question. Let me just get back. Yeah. So from my point of view, whenever we are in our standardization, we standardize it, a specific domain. We create rules. We create common understanding of our domain, and whatever object this domain represents, I would call that a domain object. For example, a scenario. For example, an action in a scenario. For example, a measurement value in an MDF file. These are typical domain objects, and to share these domain objects, data formats are used. I know probably there might be some other definition of domain objects, but I would define that as a general idea in a domain of things that represent this domain. So probably like that. But we can discuss that on that a little bit later, of course. Yeah. It's just to clarify what I think about what a domain object is.
And then I think there's 2 or 3 questions that are asking for elaboration between format and language. I'll leave it up to you to decide if it's a good time now to address those or if it's better to do it afterwards.
I have some slides to language, yeah, and yeah, it's interesting, yeah. So probably we'll proceed with my slides, and whenever we come to these slides, I probably can answer these questions. So okay. Let's now talk about domain-specific data formats in standardization. So we are right close to the language right now. Anyway, so how do we specify data formats as a normative output of a standardization process? So that's I already talked about that. Many standards define data formats as normative output. Just to enable the parties to share these domain objects and to encode these domain objects in a specific format. And there are several ways to do that. So how can we define data formats in a standard? And the one that we use very often is we decorate generic data formats, which means we have data formats that have everything in place. They are extensible, for example, like XML, and to add some semantic sugar or some domain-specific knowledge to these generic data formats, we define, for example, an XSD, which is domain-specific to decorate a generic XML data format. That's what we do, for example, in OpenSCENARIO or in ODX, or for example, with protocol buffers in ODS, where we have some kind of a data schema that just sits on top of a specific generic data format. The second is we can create domain-specific language. That's what we are doing in an OpenSCENARIO 2.0. We define our own our own grammar, just to make the experts able to have a good understanding about their domain. So with languages, we can easily guarantee that we are very short. We have a good information density, a high information density, and to make expert read the encoded domain objects very good and very well. So it's just it's just a small step from the domain to the data format. We can implement domain-specific binary formats. This is what we're doing probably or such in MDF, where a measurement data format is defined that represents the measurement value in a binary format. And sometimes we have technology-specific reference implementations, which which probably uses REST or C# or other technology-specific implementation to represent the domain objects. Yeah, these four. And the first one is probably worth a little bit, a couple of examples. When we are talking of decoration, we use XSD in many standards: OpenSCENARIO, OpenDrive, ODS, ODX, OTX. We use an XSD to add domain-specific knowledge to an to XML. When it comes to databases, for example, so we add a domain-specific database schema with definitions for tables, rows, and constraints. That's what we are doing in the Open Data Services, where we have a generic relational database, and we define the database schema on top of that. And last but not least, we have sometimes GPL interfaces where we defined MCD interfaces. We have IDLs where we can put our information into, which means we have a specific language, which is IDL, and then we just define our domain on top of these data formats. Now the takeaways from data format are the data formats encode domain object. So as I define it, for representation, storage, or exchange. So whenever it's about representation and storage, or whenever it's about storage or exchange, you can be very sure that we are talking about data formats. That we talked about that encoded data represents an original, which means, for example, an OpenSCENARIO 2.0 description represents the basic idea of a specific scenario, and the data formats represent encoding concepts, which means is that both are also some kind of models. And domain-specific data formats use decoration like domain-specific languages, binary formats, reference implementations, and so on. Okay, data formats and models in standardization. So how are these two concepts used together when it comes to standardization? So I give you a short list of example models that are usually used during standardization. And on the left side, I have some kind of example models, and the user guide, I would probably now see as some kind of a model. It's some kind of a descriptive model only, but nevertheless, it's some kind of a model. So, and on the right side, you see the data format, which means that even the models we are using, the domain models we are using in the using during standardization, if we want to share them, they also have to be encoded in a some kind of a data format. And when it comes to standardization, of course, we have the user guide, and this user guide is encoded in ASCII doc, and it uses some images, it uses pieces of plant UML, and probably it's also the classical ones are represented as Word format. And the UML domain model, we have several among our standards. They are encoded in an enterprise architect proprietary format. You can encode them in blunt UML or in XME. XME is a standardized format that represents UML model, and you can also export XME from the enterprise architect, for example. So you have to have, of course, database key schemas, which are represented by the data definition language and SQL. We have ontologies in web ontology language and RDF, interface definitions in IDL, interface definition language, C# and some proprietary. So sometimes interfaces are just defined in some kind of a table, which says this is my function, this is my first parameter, my second parameter, and this is the result. So they are not always defined in IDL or some kind of technology-specific format, but also some kind of proprietary. And the domain-specific language, they are defined in Vakuznauer form or in rules or in formats that are provided by RDLR or Lex and Yak or something like this. It's just languages that are able to generate parsers out of that for domain-specific languages. And beyond that, you always you often have some rules that specify not only this syntactics of this domain-specific language, but also the syntactics of the specific language. Let's just give you an overview about the models we are using and the formats we are using when it comes to share these models. When it comes to other typical artifacts of a standard, we also have a look on the primary modeling goals, just to make sure that we can think of these artifacts about models. So user guides as its primary modeling goal, the human readability, which means that whenever you provide your standard, you want to have a piece of readable explanations that gives you a good idea about the domain you're describing. We often have the domain model, which the primary modeling goal is to eliminate ambiguities of plain text by using formal methods. It's just to make sure you are able to have some formal description of your domain. And of course, the data format we already talked that is often some kind of a normative output of the standard. So it ensures the primary modeling goal. It ensures the interoperability between systems, and primary the machine readability. Of course, we have human readability in here, but anyway, today I think it's just a primary goal that someone reads domain object in a specific format and someone writes the specific uh, the domain objects in some specific format. And of course, the examples, they have normally a non-normative instance of the data format, and they just should increase intelligibility, establish best practice. So which gives us some hard time with consistency issues. And this is the case with any of the standards groups I've worked with. Um, when we have so many sources for describing the domain, we have consistency issues, like the user guide explains the domain with tables and diagrams from the domain model. So the user guide includes examples. The user guide explains the data format. Examples must validate against the data format, and examples must be consistent with user guide domain model and data format usage concepts of data model. So like an action in the data format of OpenSCENARIO and the data model of an open scenario is also some kind of a XML element in the data format of OpenSCENARIO. So these which means these sources are heavily related, which brings us to the questions: do we need a single source of truth? And I think we already answered this a little bit. That when we remember that an original must usually be represented by different model with different modeling goals, we could get to the conclusion that the single source of truth is not only out of reach, but it is not even desirable. Think of the apple pie. You would not eat an apple pie recipe when you want to experience the taste of an apple pie. So in the same sense, I think we can it is not we were working on the wrong problem when we are searching for the single source of truth in a standard. We will always have a user guide. We will always have a domain model data format, which just have to be consistent. But what we can do, and probably uh, this is a great opportunity when we are facing the reality that there is no single source of truth here. We can do everything that makes our life a little bit easier. And what we did in the standard so far is that, of course, we can minimize the number of artifacts. So this is also some kind of reduced redundancy, which means define the things in probably not on different on different places in the standard, and do not repeat yourself. What we can do is we can use automation for consistency check, and automation is a great tool when it comes to check the consistency, instead of making everything into a UML model or making everything in a old model or something like that. And what we have to prepare to is some kind of a model-to-model transformation for generating consistent representations. And what does it mean so far? This could be that, for example, define your domain model in UML and make it so formal that we can create documentation out of that, that we can create the XSD data format out of that, and probably for tools also be able to create code out of that. So that's what I said at the beginning. That's my passion. take a model and generate something out of that, so just to make sure that everything is consistent, which means that brings us to the conclusion that though we cannot guarantee some kind of a single source of truth, we have still some tools to get close to it, and that is probably something that when we do standardization, this is probably a good opportunity to be consistent then. Choosing the right data format. So this I've copied a wish list from OpenODD about the data format, and I would just give you the requirements of the data format. It should be searchable, exchangeable, extensible, machine readable, measurable, verifiable, and human readable. These are great requirements for a data format, and I want to add some others which are required in some other standards. For example, read optimized, write optimized. They should be popular and well known, open source, and should have a great tool support. So we see it's not really easy to get the right data format, and I show you some example from measurement values that these requirements are sometimes contradictory. So let's go to a short example of measurement data, and this is something we evaluated during the big data concepts of open data services. So this image shows on the left side emitting data sources, and in the middle a measurement tool that just gathers the measurement values of the emitting sources. And on the right side, you're seeing you're looking at that a file that should store any of the measurement value that is emitted by the sources. So when we have this use case, so the most important things for the tool vendors that that provide tools for recording measurement values, the two most important things is to get the values safely onto the disk and fast. So these are the only two requirements that count when it comes to data recording. So which means that any other requirements could probably not be fulfilled. And we end up in a specific data format, which is probably also represented by MDF. So MDF is a data format that enables measurement tools just to dump their measurement values off. And we are now looking at another use case of the same domain, which is then read the measurement data. So once the measurement data is written and is probably in an unordered and high entropy file, it comes to the use case that you have to read the measurement data, and it's some kind of the warm principle, write once, read many times, which means that whenever you have written the file, you might be it might be wise just to transform the write optimized data into a read optimized format, and then with a big data with the big data in mind, you're also able to that measurement data is structured and be able to be distributed among different servers. This should just show you that even in the same domain, and even if you have requirements on the data format. Sometimes you just have contradictory requirements for the data format, and in these cases you should be brave and bold and should be able to transform from one format to another, since you cannot just fulfill any of the use cases with one format. And it's the same when you are putting your data into a search engine, for example. So the use cases are such different that you have to transform the data into another format just to fulfill your use case. And it brings us to the takeaways from the data format and models and standardization. That we have artifacts in our standardization process that represent the target domain of the standard. We have different representations with different modeling goals. We never reach single source of truth, but we can get close. So there are some strategies that bring us close to that. And the data format itself may not fulfill all contradictory requirements. So in these cases, we rather use transformation than say searching for the holy grail of the golden data format. Now, next chapter is about connecting different standards and system, and I just copied a picture from OpenDDD, which illustrates basic testing framework. And you just see that while testing and validating data against specific ODD, you are using a couple of different standards. I mean, we see here OpenTest, OpenODD, OpenDrive, OpenCRG, OpenScenario, OpenMaterial, which is by BMW, OpenLabel, and OpenX Ontology, which are a lot of standards just to be integrated into a validation. And rather than giving you some kind of a solution on that, I just want to point out what issues we are usually faced with when dealing with different standards. So we have different standards and systems, so we often have compatibility issues. So when we want to move back and forth between different standard or system that represent overlapping domains, which means we have to deal with two standards or one one system that that is used by one vendor, and we have to translate it somehow into into a standard. We have integration issues. This is the case like the picture before, when we integrate multiple standards and systems with their data formats and interfaces into a higher level system, which means we want to make use of different standards and integrate them together. There are system boundary issues. This is often the case when you already have a complementary building blocks in a standard where you want to refer to, which means that you are building your standard on the on the dependency of another standard or another system. And other issues you might have here are legacy issues, when you're probably moving from one standard or system to its successor. This is often the case if you have some kind of migration like we have from Open Scenario 1.x to Open Scenario 2.0. And I have some quick tips on these kind of issues, but when I have time, I would probably show them later. Otherwise, I would just finish the slides and then come back to these issues of system integration and how we can probably face that. Okay, these are the compatibility issues, and we are right now at the chapter of meta models, and instances. So it's not I think it's not a big deal about meta models. It's the question is, what is a meta model? So a meta model is a model. It's still a model that describes the structure, rules, and relationships of other models, which means we on one hand represent other models, have rules for that, and we then the relation meta model of is then useful for describing layers of model. And I would just give you an example of such a layered model. When we talk about, for example, the layered model of OpenSCENARIO 1.x, so we have 4 layers of models right now, and it's always the relation is always that the underlying model, the model above is the meta model of the next underlying model. So when it comes to meta models, you see on the right at the bottom, you have your domain-specific instance encoded in a specific data format, for example, in XML, and you are specifying a specific scenario where you probably use my event that you call your event, and that my event is an instance of the domain model, which is represented by our OpenSCENARIO UML model, and also by its generated XSD. So my event is then an instance of an event, which is a class in our OpenSCENARIO model, as well as actions, and an event has actions, and an action has a properties on an attribute and everything like that. So, which brings us to the next upper level of the model layers, which is the UML level. That UML is the meta model of our domain model, and in UML you have elements like association, classes, and attributes. You see that name of the action is an instance of the attribute, action is an instance of a class, and the association between events and actions also an instance, which brings us to the rules, how our domain model looks like, and that is just defined by the UML element. And this is generic, and the model layer 0 and 1 is domain specific, which makes us able in our standard to rely on a generic model like the UML, and model above UML, which is called the MOF, and which makes us able to have some kind of relations between the models, which means that the domain model, the domain model is a meta model of the domain object. The UML is the meta model of our domain model, and the mob is the meta model of our UML. And by this, it's sometimes useful just to be just to remind on which level you are. Are we talking about the meta model? Are we talking about the domain model, or do we even talk about the domain object, which is encoded? And usually we are defining the domain model in the standard. The domain object is non-normative, which means that these are the instances of the domain objects, and the domain model just defines the rule how to make the domain objects, or how to validate the domain object. So right now I have some 15 minutes left for some quick tips. These are just this part is just contains private opinion, so probably it's also some some room for discussion right now. And I have some things about usually used mechanism or technologies which probably are helping us in our modeling groups, just to remind which problem to solve. So the first one is on XML. So just stated, XML is not a domain model methodology like UML. So moreover, XML describes a textual data format which concepts are based on a hierarchical structure. So I know that yeah, XML is very good to read and very common, and it's very popular just to take XML as a format, just because everyone knows it. There is no knowledge needed. Tools are available, so that's perfect. But we have to have in mind that XML describes a textual format which describes hierarchical structure. So which means that whenever we have complex networks as our domain objects, so when our domain objects primarily form a shape primer a network, so we have to check whether XML is the right format just to describe it. The same is when XML is very good when we do not need random access. So usually, and I've worked with a couple of XML parsers and big XML files, and still XML files are usually written and read as a chunk. That's also the only way to validate them, to read them as a whole, and then decide, is it valid or is it not? I mean, you can still run through the first half of an XML, but not when you want to validate a XML, for example, with a schema. And that's something you have to have in mind when you are choosing your data format. So whenever you have big chunks and you probably need random access, and this is especially true when we have some kind of network. XML, check whether XML is really the format that you would use here. And we all often talk about human readability when it comes to XML, and human readability and writability only pays off in XML when you really want to use XML editing. As soon as you are want to use tools or something like that, you really have to abstract from the textual representation XML, which means, for example, if you have a scenario editor for 1.x, you would probably not do this on a base of XML, but on the base of some kind of property sheet or UI or something like that. And this is a lot of mapping when you are using XML. Next one is that composability and extensibility are hard to achieve with text files and with XML. We have the example in OpenSCENARIO where you refer objects that are outside of your own XML file in other XML file, and this is simply something that is not in the capability of an XSD or of a schema validations. You cannot validate elements outside of your own XML file. So this means that that XSD validation is just not enough to ensure the the semantic validity of your file. You can still use XML. That's what we are doing, but you have to be aware that this is not in the modeling goal of your XML data format. Okay, some thoughts on domain-specific languages. The domain-specific languages are programming languages designed to solve a specific problem in a particular domain. So they use the expert vocabulary and domain knowledge to increase productivity among experts. So a high information density for experts. They provide an excellent expression power and readability for experts. So human readability is as a big factor in DSL. So writing these kinds of small programs is really in the scope of this of the domain, which means that really having editors and tool support for these languages is essential. From my experience, you should probably resist to support extensibility to leave the small area of knowledge. So on one hand, DSLs are really great when domain-specific languages are really great when you want to cover a really small and precise part of a domain and knowledge. And then it often turns out then whenever a DSL performs really great, everyone says, okay, this is very good, so let's use this DSL everywhere. And then it's the moment where it just does not pay off anymore. I mean, this is the strength of the domain-specific language, that it's not general purpose, and before you extend your domain-specific language to support every programming, you should really think about how to solve that probably in another way. It's from my experience, it works best on sequential programming where instructions are executed in a predefined order, which means you have the first instruction, second instruction, and so on. And the idea is that the expert knows that the first instruction is executed first, then the next one. I mean, there is also some room for parallelization, but from my point of view, concurrent execution is some kind of challenging. It just does not naturally fit the writing process of the of your language, which means I'm writing the first instruction, and I have in my mind that this first instruction is then executed first. I mean, it's still possible, but I think it's challenging to have concurrent execution with the DSL. And what probably is not beneficial is some kind of event-based execution. When you have event-based execution, it's you just give up the benefits from a domain-specific language. In my point, from my point of view. Okay, that's really some kind of personal opinion. So another thing, what I experienced with domain-specific languages is that they are easy to process syntactically. So, and it's much more difficult to provide semantic integrity. For example, when your domain-specific language allows you to define variables, that's really easy to say. Okay, I have the data type, I have the database, the variable name, and that's my definition. What you really have to do is probably to ensure that in the same scope there is no second definition with the same name of the variable, and this you should make this part of your domain-specific language. And this goes right beyond the syntactical definition of how to read in the chunk of text. This is really about semantic integrity. It's the same as if you are supporting if statements. You probably have to ensure that there is an else statement or something like that. So this is or some kind of a return statement in a function. This gets some kind of difficult, and especially, and this is the last thing here, is that DSL lack native tool support like IDEs or syntactical sugar for editors. I mean, you can still provide this, but this is just whenever you choose a domain-specific language for your case, you just have to have some kind of a concept on this. But all in all, I think it's the domain-specific language is just a great way to be very precise on a specific domain. On ontologies, and just right at the end right now. Ontologies are formal explicit description of concept relationship within a specific domain. It means that it's quite useful when it comes to use them in standardization as we're describing as a domain. They link data from different systems, so they are probably a good tool when to integrate things. Provide a validation framework, support reasoning and inference, which means you can also put some kind of semantics into these ontologies, and that's probably also the main modeling goal on ontologies, to define semantics. And on the other hand, they are time-consuming and costly to develop. I told you before that I was in the data group with rule-based validation of calibration data, and it turned out that maintaining the rules is very hard to achieve. And this is really time consuming, and it's not always consistent. And this is, I think it's just challenging to do that. And the ontologies suffer from open world, closed world assumption. I probably come to this again and in another example. And they suffer from the dual character of propositional logic, which means something is either true or fails. And they also have a lack of standardizations, lack of tool support. When I worked with ontologies, that was a basic disadvantage, that tools are not very high-end support the ontologies. And just that's also my personal opinion, that ontologies have not met the expectations so far. So rule engines has been widely replaced by probability models and AI. So we had a time when ontologies and rule engines were very popular, but it was just so much work to keep everything consistent and just do that everything pays off. Where ontologies and feature-based models are still used is probably when you buy a car and put your things together, and then at the end press the button and the car is then produced. So this is a good example where they still work. But I just want to show you some what I want to say with open closed and open world and closed world assumption. What we really have often with ontologies. Um, so think of a system that has three colors: red, yellow, and blue. And in a closed world, which means it's pretty clear that there is not any other color. You have whenever you have my car is not blue, then it's the same as you say my car is yellow or red. In an open world where you cannot say there is no other color than red, yellow, blue, you just don't know. You know, you just cannot infer any other prepositional logic than my car is not blue. And the same is when you have some kind of condition, sun, rain, and I have this also from OpenDDD. Then when you say operation is allowed when not rain, and then it's the same as you say, okay, operation is allowed when sun. This is perfect when you are in a closed world. When you are in an open world and want to be able that your condition is extended by someone, for example, snow will be added to the conditions. Then you can still infer that, or you can still have this rule: operation is allowed when not rain. But the question is operation allowed when snow? And this is exactly the case whenever you operate in an open world. You have to make sure that your rules are still valid, and that makes it very, very difficult to deal with rule-based engines or with ontologies, in my point of view. And the last one is on UML, and so when you use UML, and from my experience, when you use it as some kind of a drawing engine for diagrams only in a descriptive manner, the benefits are very small. So you have not many benefits in just drawing pictures, you know. So data models are good candidates for formal models, especially for glass for class models or for class, you can say class diagrams. So that's what we also did in a couple of standards like ODX or OpenSCENARIO. We saw this as a data model, and we modeled this in UML. You still need a modeling guideline. So UML is just too generic. Whenever you make your model, you have to define a naming conventions. You have to define which type of associations you are using. You probably have to define whether inheritance is allowed or not. It's just in the case that for rules that whenever someone wants to extend or change the model itself, you have to make sure that that the conventions are met. Otherwise, you really get some kind of inconsistency or problems. When you use UML, use profiles. This is also a support to add domain-specific knowledge to your meta model, which means you're adding a profile to UML, and you can then use this into your domain model. As a good example for what we once did is we defined the stereotype deprecated, which is not a UML concept, which is just a concept defined by our domain. But whenever we put this stereotype to a class, we define a semantic that this class has been deprecated and should not be used anymore. And there are some other stereotypes and in UML profiles that we benefited from just to add some knowledge, domain-specific knowledge to UML. We should be aware that blunt UML represents rather diagrams than full UML model. When we use blunt UML, it's just great to integrate diagrams into ASCII-doc, for example. But on the other hand, when we use blunt UML to for modeling, we are then on the level I just have in the first line. You're just using UML as some kind of a drawing engine for diagrams, and blunt UML does not have such the power just to for example, you use XML, UML profiles or something like that. You can still use it. That's not a problem anyway, but you must have to be aware what you're doing and how you're doing. When you use XML, it's limited when defining networks, for example, references. So sometimes it's just a good idea to create an XSD from an UML, and in UML you define all the references and that make up the network. And the XSD you are generating is just uses just hierarchical model of XML, and you then have to have tools, for example, to solve the references, especially when you are referencing objects in other files. The references in UML are still valid, but they cannot be transported to XML. So UML has a standardized format, but lacks tool support for code generator. So that's a big disadvantage of UML. So as I said, I like to generate code out of models, but to read XME is every time giving me a hard time since there is no parser or something like that for that. Okay, I'm ready now. Okay, UML is limited and less powerful for defining APIs. In these cases, you should probably use IDL or other, or when you're defining REST APIs, you can use OpenAPI, which describes especially REST API. So whenever you are defining APIs, so UML is probably not as good as for data models. With this said, I'm ready to take your questions right now.
Thank you so much, Andreas. So there are lots of questions. I'm trying to see if there's a flow that we can set up through them. I think a lot of the questions are oriented towards the language. I think a lot of them are coming also from the OpenODD perspective. There was scrolling through, there's one of the earlier questions by Christopher, which is, could you please spend some words about database schema, different levels, and data model?
Just let me have a look at the chat right now. Okay. Is it somewhere in the chat right now?
Yes. Good luck scrolling through them. There's lots of questions, so I just picked one at halfway at random.
I can probably orient in the time. 14:30 or something.
14:47 is the question from Christopher. I mean, a lot of these questions, I think, are all coming from the same thing, and maybe we can put them all into a bit of context here. And all of the OpenODD guys here will hopefully correct me if I state anything wrong. But coming from the OpenODD group here, we have, of course, the project is aiming as of today to define.
Okay, I have it right now.
To define a data model and have a corresponding database schema and a language that represent this to some form, right? And I think that's the main background to a lot of these questions. The question coming from Christopher in this case is from the database schema and the data model. And then we have a couple of other questions in the chat that are coming from the language side.
Yeah, so from my experience, when it comes to databases, and that's what I'm, what we in our company designed for a lot of years, is that you try to map your domain to, for example, a relational database with foreign keys and everything like that. It's if this is the questions, and you end up in a set of tables and relations, entity and relations, and rows and everything like that, and then you're able to describe your domain with this data model, and then leave it to the database to store the data. And you have still in the case of a relational database, you have SQL as a descriptive language, which means you are defining what you wanted and not how to get it, which means it's completely transparent to you how the database stores its data in files or formats, or if it's column based or row based or something like that, and you just use the query language to define what you want, and let the database decide how to get it. So this is probably how some data model is described best when it comes to a database schema. Yeah.
Maybe a quick comment from my side. So this is Christopher speaking.
Yep.
I was asking about some words about this topic for good reason, because we have discussed, so what is a database schema, what is a data model, what is a model, and so on. And you started also with modeling stuff and so on. And then you say, okay, we use maybe UML for the representation of a data model. And typically when you start to develop data-based schemas, you have different levels. It's on a conceptual level. Basically, this is typically an UML part. And then you have this logical level, and you have this physical level. And those are different representations and different forms of, let's say, a model. It strongly depends on the view of this specific item, or you call it original, because in our case, the original is in our head, and we have to model this.
Mm-hmm. Yeah.
And that's, I think, the main problem. Yes, something like this. And this is, I think, a very important information, which maybe you could spend a few words on this.
Yeah. So yeah, I have this on my additional slides right now, and this is probably something that it's worth talking about. This is about the physical and logical level of data format. And as for XML, XML, it's probably easy just to understand that for XML, there's also some kind of logical level where you have nodes and child nodes and attributes and something like that. And you also have some kind of physical level, which is encoded text. And many of the tools of the XML editor, they support the logical level, which means they give you some kind of a tree of nodes and something like that. And it's some kind of similar with a database with a logical layer and a physical layer. On the logical layer, you have tables, rows, and constraints, and there might be some intermediate layer where you have table space and database files, and probably can also manage this one, but just on a lower level. And right at the end, you have some kind of a physical level where you are in a database, you store your information in a binary row-oriented or column-oriented manner, or probably have also some redundancies depending of where you have some kind of a data warehouse or of a online OLTP, online transaction database. And that is probably something that is interesting and probably important, yes. And tool support is mostly here on the logical level. Yeah. Okay. When would you like to
Yes.
get some other? I could.
So I'm just trying to. So we have here a question. Some questions to the requirements on the OpenOD language. Maybe you had this slide where you had the initial requirements from OpenODB, and you added some further ones. I think there are one or two questions to that, starting with the comment at 1459 by the data.
Is it possible for me to just jump in to ask one on a follow up on this point itself, Andreas? First of all, thanks a lot for this presentation. I think it's very helpful. Just to take Christopher's point a bit further, could you elaborate a bit on how, in your world, you're differentiating between a database model and a database schema?
Yes, I think it's widely the same database model and database schema. The database model in a relational manner is just like a set of data definitional language statements, like create table or something like that, and I think the data model is the data model in case of a database. It's quite the same as the database schema. From it's probably a little bit simplified, but I probably would not make any difference when about that. Do you have some?
I don't. I actually have confusion because in the
Okay.
OpenODD project we've been trying to separate the two out.
Yeah.
So based on what I hear from you, you suggesting they're the same thing.
Yes.
Okay.
Sorry, Siddhartha, but we have to be clear on that. We are talking about a data model and this database schema. And from my perspective, when we talk about a data model, it's a conceptual model of it can then be used for a logical database schema. It's it can be derived from that.
Yeah, I know. I think I think I know what you're talking about. So it's the same like our modeling and in some of the standards, and you probably use UML as a platform independent model, and then create from this platform independent model, platform dependent model, which is either XSD, for example, or a database schema, which then creates some a data model for a relational database, and that's probably, I think, sometimes it's just a good approach to have some platform independent model, which is called PIM, and then have some platform specific model and a platform independent model. You just transform into a platform dependent or platform specific model, like a database model, or like XSD, or like others. Yeah.
Okay, thank you.
That's probably our understanding from the data model, which is abstract from the database schema. Yeah.
And okay, then we had the question from Andreas, I think also to the requirements previously, which was about why do you think that something such as machine readable or read-write optimized is not a suitable requirement for a data format?
No, Ben, you
it's not a
confirmed
question.
this. Yeah, this was just a reply to one of a comment from Siddhartha out of question.
Okay.
So I think what we were trying to understand on that one is actually, Andreas, if you could be a bit more, maybe with examples, help us understand the difference between the language and the format, or are they the same in your world? Because I think you use them interchangeably slightly, and in OpenODD we are also trying to understand if there are two different things. Some people think they are, some people think they don't, and just want to understand how is the format different from a data format, different from a language.
Okay, I think that the language is something conceptual. So and it represents some kind of an idea. How to describe, for example, your validity in OpenODD, and the format itself, it really depends on how to share the information. It is a text format. It is some kind of a domain-specific language. Is this a set of RDF statements, for example? And abstracting from these two things, I guess you are coming from the language, and your modeling goal with the language is that you want to express something, which means the validity. And by choosing a format, you are making the decision how this validity should be expressed or shared or encoded. So if it's the same, if you just describe your validity with a domain-specific language in the first place, okay, then you just probably have the decision made for the format. Then it's a domain-specific language. But if you're abstracting from the way how you encode your language and say, okay, my language is something like a higher level concept to express validity, then it's just up to your decision how to encode your data, for example, in RDF statements, for example, in probably in domain-specific language. Then it's up to you, and that's what I want to say. It's you have a model, and when you derive a format from this model, it's some kind of a decision making. Yeah.
So would it be correct to say that every language is a format and not every format is a language? Sorry for simplifying this.
Yeah, a language represents an idea. That's what I just said. A language is from my point of view, if you define a language, for example, via Bacchus-Naur form or via an ANT-LR grammar, it's you made a decision how to encode the data, which means you made a decision that your format should rely on text, for example, on UTF-8 encoded data, and then it's a format. But that's what I said also with my slides. This is just like difficult. The language itself also represents an idea of first how to store your data. This is the first one, and the second one is how to describe. They also describe your domain, which means that when whatever your language describes, like some kind of a validity or something like that, this is also part of your domain. And in these two senses, so the language represents a format, which is a model, and your language represents your domain. Your domain-specific language represents the domain. In both cases, it's some kind of model that represents something, but it's still a format. And at this thing, you are right. Language is always a format, but a format is not always a language. Yeah.
Okay.
Sorry for
just
getting this.
No, that's fine. No, that was very helpful. That was very helpful. Just a last point of clarification on this one. So does the format not represent the describe the domain? Is it just the encoding does the format do? Because
now
we thought
it describes both, and it's a representation for both. For the idea how to encode your data, which is the decision to do it in a textual format, and the idea what you want to say with your language, and this is the domain, which goes more into the domain model. But both are when you want to, both are different things. Yeah, it's how to encode your information is data format, and what is represent, it's your domain model, I would say. Yeah.
Okay, thank you.
Okay, we are reaching the last 3 minutes of our webinar. So we have time for one short question. We have two questions. Maybe we could squeeze them both in because I find the last one funny. We get that in a second. Not funny in the sense that it's a bad question, but it's an interesting way to phrase it. First off, from Adam, what is a good example for a platform-independent model?
Especially in the case you mentioned before, if you're used in a hybrid way, like for modeling a DSL, for example, and a database schema. Because this is exactly the use case I think we're having in OpenODD.
Yeah. We have an example. We use that mainly for OpenSCENARIO, where we put together a data model, which probably has also references and everything like that, which is widely platform independent. The only platform dependencies, and that what is something we put in per purpose, are the stereotypes, then which means you probably have a data type like a class, like an action or something like that, or like a scenario, and we then stereotype this class with XSD element, which means whenever you go to a platform dependent model, which is XSD, for example, you know that whenever you transform this to XSD, this class will represent an XSD element, and we made it with any of these attributes. So I would say the data model from OpenSCENARIO is some kind of platform independent, and then we create a platform independent data model, which is then the XSD representation that's fully created out of the UML model. Yeah.
Okay, thanks. Thank you very much.
Yeah, and probably also a good example is that what we said before, we have a data model, and then we create a database schema out of this data model, where the classes are tables and the properties are rows and something like that. And that's a good example to start with a platform independent model, and then transform that into a platform specific model, like a schema, database schema.
Okay, that has actually led us to the end of our session today. I think what we'll have to do, if there's any other questions, and Andreas has a couple more in chat, maybe we can, maybe there's a there's a good way we can answer them offline and make the questions available, the answers to the questions. Andreas, you and I'll have a catch up there.
Yeah,
thank you all
good
for joining.
Thank you very much. Yeah.
Thank you, Andreas, very much for your talk today. It's very helpful. And I'm sure it also led to lots more. It will definitely lead to some very interesting continued discussions in some of the projects. Thank you all.
Very
if you
good.
have any other questions after the fact, reach out to me if you have any, and I'll make sure to Andreas to make your contact available as well. Thank you all, and have a great rest of your day.
Have a great one. Yeah. Thank you
very
much.
Andreas. Thank you. Bye.
Bye-bye.